For unborn babies in their mother's womb, it is quiet and protected. However, premature babies have to leave this gentle environment far too early. They are then dependent on care in the incubator. There, a lot of touching is required for measurements and examinations, which can cause stress and sometimes even pain. At Saarland University Hospital, researchers and medical specialists in pediatrics are working on making the stay in the incubator more comfortable.
Das Erste, was die Eltern sehen, wenn sie so ein kleines Frühchen sehen, ist,
the first thing parents see when they look at a premature baby is there are so many cables on them. And it's true. But wire-free monitoring of the heart and breathing is one of the areas where we have made great progress. We can already use radar technology to monitor breathing and heart rate very, very well. And this could make many cables, with all their disadvantages, superfluous. Nowadays, ventilation is often very gentle using modern methods, but it is associated with very loud noises, namely hissing noises. And the children sometimes have this 24 hours a day, 7 days a week. And then we started thinking more and more. And this is practically the big vision, that we should examine the whole of intensive care medicine to see which sensory impressions reach the child and whether they are perhaps harmful and whether we can perhaps optimize them. In other areas, we are still at the stage of developing ideas and technology, such as noise canceling for premature babies at a distance, with directional microphones and directional loudspeakers to adapt the background noise to that of the womb. The empathic incubator is actually an approximation of the environment in the womb. The team uses different types of cameras to measure certain values without contact.
So specifically here, we want to use camera systems because we want to contactlessly measure like the physiological signals and also like emotional responses from the baby. And that is possible with modern cameras. And there are also studies which show that we can measure stress from the skin, because when, let's say, a person is stressed, there are some small changes in the skin color which can be captured using cameras, and then using algorithms we can measure them. In this setup, for example, we are using different cameras with different wavelengths. So there's a thermal camera, there's near-infrared camera, there's also an RGB camera. And of course, we can also set up more multispectral cameras.
The team faces two major challenges. Firstly, it is difficult to measure babies without contact.
We cannot tell the baby, hey, don't move. Well, the baby is obviously moving, and then it throws off the calibration sometimes. So that's like a big challenge that needs to be addressed. But then we also have tools from AI that seem to be helping us. But again, it's not perfect yet. So that's one big challenge. And the other big challenge is, of course, getting access to data like this. I think it's really hard to get experimental data from real premature babies. We have like really strict regulations where we can save this data. It's completely offline. It's saved on disks and in like really secure places in locked rooms, and not everyone has access to it.
Another sub-project for the empathic incubator is the electronic nose. It is used in other areas of the pediatric clinic to detect pathogens without having to take blood samples.
Die eNose an sich ist ja nicht invasives Screening-Verfahren.
The eNose itself is a non-invasive screening procedure, and therefore we don't need tubes or blood samples to be able to detect germs, for example. In order to be able to see whether the baby's diaper is full or empty, are there bacteria in there? There are 32 polymer sensors built into the electronic nose, and they are there to measure volatile organic substances. It can absorb these gaseous substances. And this reduces the carbon conductivity of the device, and we get a specific pattern in each stimulus caused by different activity in the device. You can then train the device to recognize certain patterns and draw conclusions about various diseases, bacterial colonization, etc. This also reduces the risk of new infection, but we can also detect old infections or the infection that the child currently has very quickly and efficiently. The integration of the electronic nose into the empathic incubator simply underlines the desire of all of us to carry out less invasive diagnostics. Professor Dr. Zemlin underlines this and takes a look into the future.
Sagen wir mal so.
Let's put it this way. When I retire, I want us to have a ready-made empathic incubator with lots of bells and whistles. It should be a wellness oasis for a premature baby.